like an expression. It's actually a syntax like a guard, so you couldn't put foo colon to here. So it's a bit too slick, is an argument. If it was colon alphabets, you wouldn't think of doing that.
Too slick. It's like saying too rich.
Too rich.
No,
yeah, you can never be too rich or too slim. Yeah. Well, or I could make it work. I think I could make it work. But the thing here is, if it, what would happen? What would it mean? It would, because the thing is, if alpha is defined, none of this is evaluated. So I guess what it would mean is evaluate this and use that value. Otherwise, use the supply one. That would work. Okay. I'm hoping to have enough time on the end for ideas and suggestions and what's wrong and what should we do next. I've got a couple of ideas, but that's a good.
I'm not suggesting it.
Yeah. It's reasonable that it works unless we've not thought of something. Yeah.
Complicated.
It's pretty complicated. It's not going to complicate it by much of a percentage. Yeah. So while we wait for the others, we'll just any recaps?
So diamond something.
In your define, if you leave off the assignment arrow before the first curly brace, then it's a syntax error?
No, it's not a syntax error. What it is what it is. So, for example, here, well, if I define sum is alpha plus omega, for example, let me just do that. Now, you're saying if I omitted that?
Yes.
Okay, what this is, in this case, is a function with either a undefined name to its left or a predefined name to its left. And in APL, that can have, depending on what these things are, can have a meaning. So, for example, we'll come on to these next. Just supposing this was, instead of being a function, this were an operator, and that were a function, then that would be syntactically correct. But at the moment, I think that's probably bad news. I mean, it's completely analogous to some A divide, and that's probably a syntax error. Well, yeah, that is a syntax error.
Okay.
Yeah. Any more? So somebody else was saying. Any other recap?
Diamond is strictly a new line. They're synonymous.
They're
synonymous.
In Dfns, yeah. In Dfns. The only, what do you think? I think there are some considerations about whether you can interrupt. You can't interrupt in the middle of a diamondized line, but you can interrupt. When you hit an interrupt when something's running, it waits to, it won't interrupt in a diamondized line, it'll interrupt between lines. But I think that's the only.
But between diamonds, an expression that returns a result still terminates the function.
Yeah, that's right. It's synonymous in that. Yeah. If I have a Dfn that says 3 diamond 4, the 3 would still terminate the Dfn. It wouldn't go on to, as if they were on separate lines. So they are synonymous. And they're implemented. I mean, we could, maybe this is over a beer thing. They're implemented. The Dfn diamond, although it looks the same as the Trapfn diamond, is very different, implemented in a very different way. It's implemented in a much simpler way. Okay, what I'm going to do is tell Jonathan to switch on the recording, and we'll start again. We'll carry on. You guys will. They might have found a better gig to go to. Jonathan. You can. Oh, it's been recording. We're on already. We're good to go. John's just come.
No, it wasn't until I found coffee. It was supposed to work that way.
You found
I
something?
wasn't confused until I found the coffee.
Oh yeah, no,
It's supposed to go the other way.
Does that to me. I forgot they were recording this. I'm trying to think, desperately think what I said. Who I offended. I know I offended chemists at some point, but hey. So where have we got to? I think we nearly got there. I'd like to do. No, I need to do a little bit more. We can mop those up. Okay. For those of you that, oh no, okay, we'll skip this and carry on. Right, we've done that, haven't we? We've done Terry power calls. Right, one of the things. This is. Let's mop up. There's a fundamental difference between. This is one of these strange things that people who are have been using APL for a long time find this a bit strange, and people that are completely new to APL find that you cannot explain to them that this is a difficult point. It's just really easy. It's only the APLers that find it difficult. Here is a Dfn. And one of the things you can do within a Dfn, of course, is define inner D functions. I mean, the thing is completely recursive. And that's one of the beautiful things, is that you can have strictly local functions. As we saw in the main function, we said sum is plus slash and things. So one of the things, let me just trace this. This is probably the way to see what's happening here. So this is, we're just going to name an array, scope. So this is just a character vector. Now I'm going to name a function. So this is just naming something. Nothing's been executed. I'm just naming a Dfn. Is this okay? This is nothing strange going on. Now I'm going to name another function. So if I do a paren SINL, I've got various names. And now I'm going to call sub 0. So if I look at what's scope, what's the value of scope got in it? It's got the 7-item character array lexical. And now I'm going to call sub 0. And it's going to define another variable scope. So there's one defined at the outer level and one defined at the outer level and one defined at the inner level. And this one is dynamic. And what APL does, as you know, is just look down the stack. When you mention a name, it just looks down the stack, and the first one it finds it's happy with. That's just APL for you. And then what's going to happen here is sub 0 is going to call sub 1. And it's going to refer to the variable scope. Yeah? And a $64,000 question is what does it see? And there are two possible answers. The dynamic scope rules that traditional APL has is that, and sorry, I misled you there, maybe erase the last minute of talk. The dynamic, traditional APL has dynamic scope rules, and what this means is that when we reference a name, it looks down the calling stack to find the most recently, nearest the top, if your stack grows upwards, name, and it uses that as a reference. And that's called dynamic scope rules. And more modern languages, I think, that's a little bit what the politicians use, spin. I'm using a little bit of spin here. Use a different mechanism called lexical scoping. And the way a lexical scope works is that the name, it looks at the whole definition of the function, and it looks upwards and outwards until it finds the definition of this name. So when it looks outwards, it's not seen within this function because that's hidden in there. It's seeing the name at the top here. So when I want to know what the value of variable scope is here, it's the one at the top. So I'll go through this again. Sorry? Yeah. Well, what I can do here is to say what's in scope. Hi. You're coming to see the Dfns? Yeah. Good. So if I say which scope, it says lexical scope. So let's just go through this again. So we're going to call sub-0. Within that, I've got a scope and it's okay. So when this function, can you see the mouse? When this function refers to scope, it's seeing this one. It's looking. FYI, C works exactly. If you're a C programmer, this is just the way C works. There's no trickiness in it. And in fact, the Lisp community changed from APL type scoping from dynamic scoping to lexical scoping when they changed from Lisp to Scheme.
I don't understand sub-1. What is it doing?
All that sub-1 is doing, it's a function. We know it's a function because it's naming this function, and all it's doing is this is an array and this is an array, so it's just binding to two items. The problem with APL is it's a bit hard to tell whether two things are binding together to make a two-item vector, or it's a function call. And in this case, it's just maybe I should have put a comma here. That would have made it a little bit easier. So it's just producing a two-item vector. But the point is, when this is referring to scope, instead of saying where was I called for, looking down the stack, it just looks in the definition of the function, at the lexical structure of the function, the way it's laid out on the page, and it looks first of all to see if it's defined within this enclosing braces. Otherwise, it goes to the next the braces that enclose that and looks out there, and if it's not in there, it looks in the workspace.
It sounds like a nightmare to learn.
Well,
I mean, you have a mindset of local, what local variables mean.
yeah.
I don't even see why sub-1 could be defined when you've gotten in the middle of sub-0. You haven't even gotten to sub-1 yet.
Well, no, that's right. What this does is it names, a Dfn in this case is an expression preceded by 0 or more, 1, 2, 3, 4 definitions used in the evaluation of that expression. Okay. So this count the right pointing fingers. 1, 2, 3, 4 at this level. Okay. So there are 4 definitions, and it's defining one array. It's naming an array, and it's naming 2 functions, and then it's naming another array here, which is a result of applying this function to this array. Okay, and how do we know what this function? Oh, here's this function here. So it calls this with omega set to whatever omega is. I mean, this is a sort of abstracted function. You have to work quite hard to make an example that shows this. Yeah.
So what does the stack show then? The stack shows me that I've gotten.
Oh, that's interesting because. So what we've done at the moment is call sub-0. So let me put line numbers on if I can remember how to do that. Hang on, if I put, how do we do that? View line numbers. Okay, so what the SI is saying, that on line 12, down here, line 12 of which called something, there's line 12, which then is suspended currently on line 5. And we have both an inner and outer scope defined.
But it doesn't show me line 2 of sub-0.
Well, okay, and that's a good point. There's a bit of terminology here. What we do, we call this whole, when we say, okay, this is like how many triangles can you see in this picture, sort of thing. How many Dfns can you see in this picture? I can see 3 Dfns. There's which, and there's sub-0 and there's sub-1. Yeah? Yeah.
That's what I see.
Okay, that's good. But when we talk about, there's somehow, which is somehow, given that I've also got a mean Dfn, which I define in my workspace, and a sum Dfn, we need something to define, to describe those, and we call this whole thing a capsule, the capsule which contains inner Dfns. Capsule's a word that the Dfns group sort of came when we were talking about this thing. We needed a word to say, because when you edit something, you edit the capsule. This is when you trace this, you see the whole capsule in the tracer. It would be possible but undesirable when you trace this stuff just to see these little guys pop up out of context. But we show you the lexical context. Now I'm tracing. We show you the capsule is put into the tracer.
I think that's very helpful.
Yeah.
That clarifies things for me that I constantly have trouble understanding in terms of define.
Yeah. So there's 3 Dfns but 1 capsule here.
Yeah.
Yeah.
But if you trace through a traditional function and you have defined a d function in itself, I don't think it would jump up and go in it or it.
No, that's a difficult. The boundary between tradfns and Dfns is sort of all, it's like the Balkans. The boundaries are a bit difficult, so we have to make some choices. There is a. If you stay in a Dfn world, it's quite simple. I'll come back to answer your question in a moment. And one of the things is that all of these definitions are strictly local to the capsule. If this capsule were to call another capsule, if here I call the mean function that we defined over here, when I'm inside mean, I can't see any of these local names. With a tradfn, any of the local names in one function are visible to the names in the calling function. And that's the dynamic nature. And effectively, each function provides an environment in tradfns to its calling function.
John, again, this has been confusing me in previous years and now. You were using the word local in introducing this section.
Yeah.
This is the first time I actually made this point, which I think is very hard for me to remember. I was wondering, is it local or not? Because I'm used with trad functions to find locals by seeing them named in the header.
Yeah, yeah.
So here, I have to, everything is local.
Yeah.
But not the Dfns. Sub-1 is not local.
But the functions.
So no, hang on.
Yeah.
Sub-1 is local to this capsule.
But it's
Okay.
visible from sub-0.
Yeah. Okay. They're all. If you were a C program, have you written some C? No. Okay. You're lucky now. Okay. Well, in C, what you have is you have a file. That you can edit. You edit a bunch of stuff in a file, and your program, like Dyalog APL, is 200 or 300 separate files, and they all get mushed together into a building interpreter. And within a file, you can define a whole bunch of functions, and you can make those functions local to that file, so that functions in other files can't see them. And that's exactly the same. We could have called this a file, only it would have been a confusing term. Within this capsule, these definitions are local to the capsule. So if it would, I'll show you an example of that in a minute. If it were to call another capsule, all of these definitions would be hidden. So when a Dfn capsule calls another capsule, it doesn't provide an environment. You start from scratch again. But within this, there's two levels. There's within this, then just as when we wrote the main function and we said sum is +/omega, num is rho omega, then those are local within a function, and therefore they're visible to the sum divided by num.
John, I think, sorry, is it Ron?
Roy.
What's your name?
Roy.
Right, I think Roy is worried that sub-0 can see sub-1. Is that it?
Oh,
Yeah.
Okay,
Yeah.
if you look at the definition of sub-1, if you look at the definition of sub-0, rather, if you go look at its name and the left arrow, rather than going inside the braces, if you look in its environment, it can see the name sub-1 below. On line 8, it can see the name.
Okay.
And it's just the same as if sub-0 and sub-1 were both defined in the workspace. They would be able to see one another. So they can both see one another, but they can't see inside one another. Sorry if that doesn't help.
I think it's very, very good.
Yeah, I appreciate. Sorry, I appreciate this. The trouble is, I'm so used to this. It's difficult for me to wind back and to remember when I found this stuff difficult, and I did.
But the problem is that if they can see each other, then you're saying, but it's not true for variables, because all of a sudden the gain for scope is completely different.
No, not at all. No, there's no distinction between names and between functions and variables in regards to this. So what we can say here is this is a name. It'd be so good if I learned that I can do this. This name is there's no problem with this. This is a name which is assigned to this array. So we name this 7-item character vector, we name that scope. Okay, and so during the execution down here, if I refer to the name scope, it would be reasonable that I mean this. Now here is exactly the same thing. This name is assigned to this D function. So when I get to here, it's reasonable that I can see both scope and sub-0. And I could apply sub-0 to scope. One's naming an array and the other's naming a function. And I hesitate to use the word orthogonal concepts. Naming is distinct from the thing that's being named. Yeah? Is that the sticking point? There's no real difference between naming an array and naming a function. Would it make it easier if this function were all on one line?
But when you get down to 11,
okay.
sub-0, sub-1 are defined, whatever that means.
Okay,
Scope
so let's
is
go down
defined.
and define sub. So by the time we get down to line 11, I've named three things. I've named an array, and I've named a function, and I've named another function. Okay, so having named those, I can now use them. And it's just, if I just go over here and do quad CR of mean, I can't remember what that looks like. It's just like here, I named this function, and I named that function, and I named this array, and so in here I can refer to those names. So here I've named an array, I've named a function, I've named another function. So here I can refer to that name. Sub-0, because yes. So the only thing that's reasonable to happen is the value of omega is passed as, which is omega, is passed as an argument to sub-0. So when I get in here, are we okay till I get to line 4? Now here I'm going to name another array, which is also a 7-item character vector, but this name, just as this name was local to this function, then this name is local to this function.
Okay.
Yeah? So if I were to refer to scope here, I could see dynamic. And incidentally, if I were to refer to, if I refer to sub-1, this is still, although it's downstream of here, it's in the enclosing definition.
Yeah. But you didn't call sub-0 till line 12, so you got past line 8, so that's why sub-1 is there.
It's been defined, yeah.
little different subjects used to be.
It's okay. I'm good.
Do we need to? I mean,
No,
it's
it's
worth
good.
spending another moment on this just to get it.
Could you run it step through once more?
Step it through, yeah, sure, yeah. Okay, so what we're going to do is to type which. Yeah, this is on the. This will be on this supplied workspace, so you can. It's on either on that stick or it'll be on the website next week, so you can experiment with. Okay, so if I do SINL, no defined names yet because I haven't defined any. If I name that array, I've just got one name and I'm suspended on line 2. Really, this is a fault in the dialog tracer. Really what I'd like, instead of this line here, I'd like a line that started here and wound all the way up here and ended here, because this is the whole thing. It's really this definition, but the tracer's not quite clever enough to do that sort of colouring. So we have to pretend, but it's actually, there's just one thing. So I'm going to execute that line, and there it's actually pushed this stuff on the front of the stack.
And what is scope and what is omega?
So, well, omega is still what we passed in. We're still within which, and scope
Is not defined.
Scope is lexical.
Scope is lexical. Okay.
Yeah. So now we execute this line and we do our SINL again. Cross CR of sub 1. Sub 0. Okay, so we can sort of see what are the definitions of those. And in the FRE that I showed you, the function results edition, a little sports car edition that I did a couple of years ago, I could just type sub-0 and it would just give me the definitions. I wouldn't have to do the code CR. Yeah?
When you run that, you can't put a stop on line 5?
Oh, I think that's a good... I didn't get around to implementing stops on Dfns. It's I'm bad. I should do that. So what I do is edit a syntax error in there and then let it run till it crashes. It's not good. People have been nagging me. That's a good thing for me to write on this. I should just do that. Initially, well, okay. In my defence, when I introduced this stuff, the only way we were going to sell this to people is if they ran faster than Dfns, if there was some benefit to using them. And I pared everything down to the bone. I didn't put anything else in. I didn't put the test to say, is there a stop on this line in? And then now, because they've sort of got a foothold, I can start squandering the performance a little bit to give you some utility. People are hooked. It's like, you get hooked on the drugs and then you start increasing the price.
But you can trace down into sub-0 now?
Yeah, so what I'm going to do now is trace. So this is an application of a function to an array, and omega has still got, that never changed. Okay, so I'm going to trace into this. Oops, trace into that. Now so far I haven't localized scope because I haven't executed that line, so scope is still lexical. That line hasn't been...
Can I make a comment before you?
Yeah, sure.
But as I sit here and look at a line which has been highlighted,
Yeah.
I have no idea if I'm in the middle of defining sub-0 on the first pass, or I'm in the middle of running sub-0 on the second pass.
Yeah, with a little experience, you can be. The thing
It doesn't go through these separate lines of...
Yeah, let me show you this. Let me just
Line
back out again. Let me just show this again. Where's it say which scope? If we run this again from the top, execute that line. Now when I move the cursor down now, it goes to this line.
Okay, thank you.
And in general, this could be not. We happen to be naming this function on this line, but actually it could be a multi-line dfun with a long complex argument on this side and a long complex expression on this side. So effectively, you can take an APL thing and you can wrap it over several lines, just one line of APL with braces in the middle. So ideally, this highlighted line should highlight the whole thing.
I got it.
Yeah.
Okay, so jump down.
So you can tell that that's just going to name that function. And if I trace it, which I just did, nothing happens. It doesn't go anywhere near that code. So we'll go down again. We go into that, and now we can see that we're inside that. And at the moment, scope has not been overwritten, so scope is still lexical. But as soon as I define that, it's there. And now I can see, amongst other things, I've got a sub1. I can see sub1. So it will call sub1 because I've defined it in the outer capsule. Oh, so here's a good thing to do. Yeah, so now if I do an SI, I've got var and scope. Now I call sub1. Ah, sorry. I wish you hadn't seen it. I wish I was dead. Sorry. Ooh, that's a bug. Let me. That's a bug in. Let me get there again. It's a bug with the editor not fixing up the. It's because Bob walked in the room. He's got. We just hit a bug. It's been plain sailing, and then left up. That's the presence. Okay, now when I cut, so this is the stack. So when I go into sub1, I don't think we can see var anymore because it's hidden. So the only things we can see at the moment are sub1, sub0, and scope. Because var was strictly local to that inner function. So we're probably going to.
The scope is reverted to lexical.
Jeepers, we're going to be nearly out of time.
Yes.
Scope is yeah. I think we should. We're going to run out of time, for which I apologise. That's my fault. I think we should leave this, and maybe we can have a separate session if anybody's interested. We've got plenty of time in the conference. It just takes a knack, and then it's not fuzzy. It's rock solid concept, but I haven't really found a way of getting it over quickly and succinctly. So I'll come back to this. Note to self: try hard. Yeah. I think it's not. I'm not ducking, but I just, given that we only got 20 minutes left, I want to.
Something, a quick question you might want to defer the answer to.
Yep.
But when you're running tracer on what? What is the right name for this kind of listing? For a listing?
I think this is a capsule. I'm tracing through.
Okay,
the
capsule.
Yeah.
How is a capsule related? What's the term for a traditional function listing?
Well, that's interesting because in a function, there's no distinction between a capsule and the function.
Then in our language, if does there need to be a distinction?
No, there isn't. The thing is, because you can't have nested tradfns, lexically nested.
But as far as the structure, we're really dealing with this listing. Just to understand,
Yeah,
we're looking
sure.
to see something like this.
Yeah.
This one can't have semicolons and local names up there, or can it? If
No.
it did, that would.
They're not meaningful, no.
Then this is not a trap-found listing. This could not be a trap-found listing.
No.
I think we need to know we're two different environments when,
Yeah.
as far as the software looking at this, the
Yeah.
tracer doesn't know the difference, but the user sure must know the difference.
Yeah.
I think we've got a name issue here. It sure help if you know which, have a name for the different environments.
I'm not sure I understand what you're.
Maybe separately, but
Okay, so we deal with
it's just been a real hang-up for me to know what I'm looking at.
Yeah.
When you use the word local, because I have a traditional way of doing some local
Yeah.
names that's in the list.
Yeah, that's true. Yeah. Well, everything is local. Names. When you name something, it's localized dynamically. You make a local name.
But I can't tell that by just looking at the listing. I've got to know this is a capsule and not a traditional listing.
Yes. Okay.
Just line 1. You just need line
That's
0.
what tells me the
line
difference.
0 is the only thing.
Line
Okay,
zero.
line 0 tells me the
Yeah,
difference
if it's got
because
squiggly,
it's got the squiggly bracket.
Yeah.
So that's the clue that this
Yeah.
is not
Yeah.
and cannot could not be confused with. You'd
Yeah,
get in trouble
that's right,
if you
yeah.
try to use something else.
And I think in V12, the quadrennial, you can call quadrennial in such a way that it distinguishes. So it's quadrenc, sorry, the name class. If you give it a nested name, it'll say 3. Instead of saying a function is 3, it'll say Dfn is 3.2 and a tradfn is 3.1 or something.
Well, because again, I think the simple user of language, the human
But visually, you soon get the hang of spotting this. Just
Yeah,
either the top or the bottom line will tell you what you're dealing with. Okay.
Not a bottom line.
No, there was
a parity matrix. Right?
there was a competition some years ago to write a function that could distinguish between tradfns and dfns called isDfn, and it was quite a difficult problem to solve.
Yeah.
And there are all sorts of tricky ways of like set a stop on it. Did that work? No, it must be a dfn.
But I think the first problem to solve is how the human can know the difference.
Yeah. Okay.
And let the machines catch up.
Right, I've got two things I must get through, and these are operators and error guards. Those are the two things in my reference manual that I haven't come across. So in APL we can have arrays, functions and operators. And an operator, a function applied to an array argument or arguments, evaluates and produces a result. An operator binds with an operand to form a derived function. So if I put +/, the plus binds with the slash to form a function, a summation function in this case. Yeah, and we can have traditional operators. APL2 has defined operators, where in the header syntax we put some parentheses to say what's going on. In the Dfn world it's slightly harder because we don't have a header to put syntax in. So what we do is in a tradfn, let me write a tradfn header will say something like Z is left F op G R semi A semi B semi C. That would be a trad operator, an APL2 operator header. So we know that this is a left operand, that's a right operand, this is a left argument, that's a right argument, and these are some local names. And of course operands can be either functions or arrays. Now we don't have that in Dfns, so what we do in Dfns is to name, we have alpha refers to the left argument and omega refers to the right argument, and alpha alpha refers to the left operand, and omega omega refers to the right operand. So the rules are, if the Dfn contains an occurrence of an omega omega, then it's a dyadic operator. Otherwise, if it contains an occurrence of alpha alpha, it's a monadic operator. Otherwise, it's a function.
You say that backwards?
I did say it backwards because in APL, or my mental model of APL, different people may have different mental models. A dyadic and monadic operators are somehow syntactically different. You can't have an ambivalent operator. I don't know why, but APLs don't do that. So an operator, so the rules are, if it's got both alpha alphas and omega omegas in, then it's a dyadic operator like this one. It better be given a right operand as well as a left operand if it's got both of those in.
In fact, only omega, because it can ignore its
Yeah.
left operand.
That's, yeah. If it's got both, then it's dyadic. If it's got only an alpha, then it's a monadic operator, as if this one were missing. If it doesn't have an alpha and it's got an omega, then we've got a problem. So what we do with that is we say that omega maps to the right operand, but we're just not mentioning that, we're just not using the left operand. So the rules are, if there's a omega, then it's a dyadic operator. If there's an omega anywhere within the braces, it's a dyadic operator. Otherwise, if there's not one of those, but there is an alpha anywhere within the braces, it's a monadic operator. Otherwise, if neither of these occur, it's functional. So an example of an operator might be a thing that applies its operand function twice, such as alpha applied to omega. There's an operator, a monadic operator. So we could say reverse, and that would reverse the reverse, or the one composed with rotate would do the one rotate of the one rotate of omega. So this guy is a function. One composed with rotate is a monadic function. So when we call this function, I'm going to choose my language carefully here. Inside this function, omega refers to the array right argument, and alpha refers to the left operand function. So here, let me copy in a more sane example. This is a handy diff, and this is a function that is an identity function. It just returns its right argument. So this is an if then else. This says if this is true, then apply this function to the argument. Otherwise, apply this function to the argument. And the coding for it is exactly this. Now, what the interpreter does is say, aha, there's an omega here. So when it comes along to evaluate this line, it says, aha, there's an omega here, so it's a dyadic operator. So it names this alpha, and it names this omega, and it names this alpha, and it names this omega. And then it starts, and it says if alpha is true, then apply alpha to omega. Otherwise, apply omega to omega.
I think I've reached my limit.
Yeah, you head exploding stuff.
But I would like to know why bother.
Well, again, okay, this is.
Because you said you were going to get to that.
Yeah, why bother with having operators? Why bother with having this particular operator?
Dfns of any sort is what you said you were going to get to.
Oh, did I promise that? Okay. Okay, I can. Let's. Okay, we're running short of time. Dfns of any kind are. What? That's a big question. Why? Effectively, that's why dfns really implement some of the concepts of functional programming, and there is a huge body of literature that says functional programming is good for you. And the analogy is when we used to have just our go-to arrow in APL, who was it? Niklas Dirt came along. Was it Dirt who said, don't do that, don't do that?
No, Dijkstra.
Dijkstra said the branch arrow is bad for you. If you use control structures, then you will write more readable code. And the FP guys came along and said, if you can avoid looping and updating variables and destructive assignments, then you will be able to write more easily understandable code in the same way that Dijkstra said if you avoid branches and use control structures, it's a next step along. So for some, this is for some, if you get into the habit of using sprinkling of Dfns in your code, you will find it does simplify some things and it makes them easy to understand. Yeah.
Actually, you said it at the beginning of why you want Dfns. You said you want to extend the world, the nice world of expressions, to do more.
Yeah.
But I don't know what that means.
I think there's a couple other.
The trade-off is a bunch of really weird stuff with localization. You
don't have to use a lot of it. There's some. You can use as much as you want.
The localization stuff. If you look on the, I found a really quite damning quote from a computer science academic. So the really cool thing to do with the internet is you can sit in on lectures at Stanford University and anywhere you like, and you can go to any university you like in the world and sit in on their computer science lectures because it's all on the internet. Mm-hmm. These guys' videos on YouTube and stuff. And there's all sorts of nice lectures, and one of those I was just Googling for APL and something, Dynamic Scope APL, and there was a computer science academic that said something like, if you pursue this line in your design, you will wind up with a very horrible localization system referred to as dynamic localization, which is used by old-fashioned languages such as APL. A bit harsh. The what's good for you guys have come to the conclusion that the lexical scope rules are cleaner and easier to reason about and less confusing. And to a certain extent, I'm convinced, but I don't have the time to make that pitch.
I think there's a couple other reasons too. I mean, first of all, it's terse. I think they're more readable than traditional function definitions. They're much, speaking from the standpoint of someone who's trying to compile this stuff, the analysis is far easier than it is. The minute you introduce even just simple control structures, and forget dynamic scoping, it'll make you crazy. Lexical scoping makes it possible to compile this stuff.
Yeah, that's like a good, it's going to be cheaper.
But as a programmer, I don't care about that.
No, that's true, and nor should you.
Unless you're telling me that the function runs faster and is therefore
we can make it run faster if you write in a simpler. The Dfns is a much simpler structure. We can make that run faster. We haven't, because we haven't got around to it. But Bob's got around to it, and he's going to be showing you that stuff.
There's other things you can do with a compiler besides compile stuff, it turns out. For example, you punch an application through the Apex compiler, and if it comes out the back end, there are guaranteed no type errors, like no quote unquote +4s in it. There are no rank errors, and we can detect a lot of length errors and index errors.
Yeah.
So even if you never run the compiled code, just the exercise of putting it through the compiler we can do a lot of static analysis in the program and catch a lot of bugs before they. And so, performance issues aside, there's good reasons for.
The other thing is because this is such a simple
analysis.
This is very simple. I mean, you must agree this is very simple. So there's very few moving parts in this. You can do some of the things you can do with this stuff is to pre-evaluate some. It's easy to do partial evaluation of some of these, so there are some performance But John, before you say this, as ever, I've run out of time. What I suggest is that we run over for say 10 minutes. Is that okay? And B, that we sort of go into winding up. Given we've got that 10 minutes, I've covered nearly all of the nitty-gritty stuff I want to do. What I didn't do is get around to pointing out the bugs and deficiencies. Oh, I can do that another time. So how can we best use our 10 minutes? Do we want to go back and review things? Sorry?
You talked about error guarding.
I can do error guards very quickly if you want to do. That's a good thing. And that's the last thing really. You want to do that?
Well, I'd just like to state one quick pitch on this last question, because I have no interest in mastering all of this. A lot is difficult for me from what I actually produce.
Yeah.
But gradually, over several years, I've come to value dynamic functions for very limited use.
Yeah.
I only use one-liners.
Yeah. A lot of people are in that position.
And I think it's entirely worth it just because you can do some concise one-liners that are very easy to represent intuitively.
Yeah.
That's enough. Everything else is gravy. If it's worth it, it may not be to you.
Yeah,
and I'd
you
say
might
the
get used
essential one-liner is very, very valuable.
Yeah. Either named or unnamed. You can either just put
named or
names in
unnamed.
the middle of an expression, or
But even unnamed is very valuable.
Yeah. Okay. Let me just show you error guards then. This is the last thing I want to show you. Let's not have food. Turn on a headline on this. Right, so what I'm going to do is to do alpha divided by omega. That should work. That's good. But if I do 12 divided by 0, it bombs in my function as it should do. So what I'd like to do is to have an error trapping in there, and Dfns have their own little error trapping thing. What we can do here, in Dyalog we have a quad trap mechanism and we have a colon trap mechanism, and
Sorry.
well, it's going to blow. That's cool. That's really cool. Right, so what we can do here is if I get a domain error in Dyalog, the code for a domain error I just happen to know is 11. So what in a tradfn I would say colon trap 11 do something. In a dfn I say 11 double colon, and what should we do? We'll return I don't know, let's return 0. I hate doing this, but let's return 0. Anything divided by 0 is or inf. Yeah? And that's an error guard. So now if I do 12 divided by 4, I get 3. If I do 12 divided by 0, I get inf. And the way this works is having set this error guard, it is in effect for everything downstream, lexically downstream of this. And if I get an error, because it's lexical, the interpreter looks upwards and outwards to see which trap is in effect, and then it evaluates the expression to the right of the double colon, and that again can be an arbitrarily complex expression. So it can contain another defect. And what is to be noted is that the first thing it does is switch off that trap before evaluating the expression, so I don't get into a trap loop.
So for all domain errors, you get that test INF?
All domain errors within this capsule, And what's different is if this capsule calls another capsule, that error is not in effect. It's strictly lexically. It's like a variable. It's not visible to called capsules, called functions. It's only within this lexical scope.
But it is within localized.
Yeah, within localized default. Yeah, I can set it at the top within a capsule, and it's in effect. It's exactly the same rules I was talking about for lexical scoping of names. This stuff is lexically scoped as well.
If this was a long function listing and for a different domain error, instead of using INF,
Yeah.
can you do that?
Yeah. So what I could do, I think what you're asking me is what else could I do instead of INF?
Yes.
Yeah. So for one of the things I could do here, for instance, is call another Dfn, giving it omega or something, and then within here I can do some error analysis within here. And so this is not evaluated until unless there's an error. And if there's an error, it just looks lexically outwards to see whether there's an 11 or a 0 is a catch-all. If I put a 0 here, this is the same convention as the colon trap or quad trap. That's just catch everything. Or 5 is, I think 2 is a syntax error, 5 is a length error, 4 is a length error, 4 is a rank error. So.
Can you redefine that further down?
In the same
So
way
say
that
after the alpha divide omega there, can I do 11 colon 42, and
Well,
then after that do something that's going to
You assign the.
if I said z gets there, because as soon as I have an expression, it game over. But if I do that, yes, then there.
Sorry, I came in late.
Sorry.
I came in late. I missed it.
Okay, and then I could say 5 colon something else. Yeah.
Uh-huh.
Yeah. So I can use the lexical rules to focus these error trapping.
Can you do 0 colon again?
0 colon, yeah, and again it's lexically. What happens in a Dfn is if I say A gets 5 on one line and A gets 6 on another line, the new definition of A shadows the old definition of A, and it's the same with these guys. It's a shadowing.
Shadows, not replaces.
Oh, what is that? No, sorry. Yeah, we can get it. No, it shadows. It shadows.
How do you ever get the old back?
You can't.
Then it's not shadow. It's gone.
Oh, it could be garbage collected. Yeah, that's right. Yeah. If you say
It's not wrong because if you
No,
you do the cutback, don't you?
yeah. In fact, I'm not sure we got time to do this justice, but I'll mention it, and then you'll all scream, and then I'll run out of the room. One of the things that happens here is when with a Dfn, the naming continually shadows.
It doesn't exist.
As you make a definition, it shadows. As you make an error guard, it shadows previous things. And when this guy fires, it unwinds that shadowing to get here. So if this guy makes an error 6, that won't trap it, but this will.
No, that's why I wonder. What happens if you change the 5 to 0?
Yeah. Okay, well that's fine. Yeah. So from down on here, that 0, it'll go to that. It'll go to this 0. That 0, that shadows. This one shadows that one. Just as if I'd said Z gets 99 here, the new Z would shadow the old Z.
Yeah. I'm just curious about the terminology.
But the point Phil was leading us into, which I was hoping he wouldn't, but he.
Sorry, no,
but as he has,
I don't understand anyway.
If I get an error here, what happens here is these things are shadowed as they are evaluated, and when I get an error trap, it unshadows back to the place where the thing was defined. So in that case, the Z wouldn't be defined.
If your second trap there was on a 5, yeah, and you've got a domain error,
my point.
Jump back to first.
If you get an error where the blinking cursor
Should I put the line numbers on?
If you get an error in line 6,
yeah,
you go to line 5.
That's right. Yeah.
And then in line 5, you get an error in ASD, ASD, and then you go to line 1.
Yeah, correct.
Okay.
What
At
if
which
you
point
get an
Z
error
would
in
no
line
longer
1?
exist.
If you get an error in
Point
line
Z would
1
no longer
and you've got
exist.
no other it'll gone.
I see.
Yeah. If you get an error in your trap expression, then that's not trapped and you've gone. And that's a good thing, because the alternative is you can get in a trap loop and then you can't interrupt and you have to switch the machine, call IT, you know. Do that. That was my timekeeping, as ever, wasn't quite what I was hoping it would be. So we've got through most of the points. If we do this again, I might split this into I forget, sometimes it takes a little while for these concepts to be absorbed, so we have to take it in steps. So is there any... what I would like to do is, in the last 2.5 minutes, is what, as the people who've used Dfns, where's the room for improvement? Where should we go? Where should we be directing our efforts? While you're doing that, I'll just show you a Dfn. This is an example of a non-trivial. This is the display function that draws boxes around nested arrays. So given, I mean that's quite a complex. The APL isn't complex. I mean, this is just, this is just APL. So the only complexity, really, not complexity, but unfamiliarity is these local definitions. Here's a function applied to an argument. Here's a definition of a function. Here's set quad IO to 0. Here's a default. If alpha's not given, default it to 1. So we've seen all of this. Here's whatever a 16 error is. If I get a 16 error, do this when evaluating this. So that's got all of the things in it.
You asked for improvement.
Yeah, sure. Where should we go now?
Don't screw around with the blanks.
With the blanks? Yeah, don't screw around with my blanks.
Because I want to be able to use a 5-character name.
Yeah. Yeah.
And still have it lined up.
Yeah. I waste my life thinking of 4-character names or whatever character name I'm in today. Yeah. One of the things we want to do is keep the proposal is that we keep your source and token separately, and then that's a nice thing. First of all, we don't screw around with your blanks, we don't reformat your code.
You have the auto format thing turned off anyway, don't you?
Yeah, we could.
If most people loaded that, it would be screwed automatically.
There's a configuration option in Dyalog called auto format, and if you turn it by default it's on, so every time you look at something in the editor it reformats everything. If you turn auto format off, you uncheck it, it just preserves leading blanks. It doesn't preserve blanks in the middle.
That's true.
It doesn't quite do it, but at least it preserves leading blank, which is why this. Whoops. Which is why that lined up the way I want it to line up. If I had auto formatting turned on, that omega would come, over, so it didn't line up anymore. So, but what we want to do is keep a separate copy of the source, and people complain about that because it's going to use more workspace, but maybe we keep them out on this. And then the other thing we can do, having done that, we can take the tokenization a lot further down for efficiency. So that's a good thing. But people complain about, somebody said, "Can I set a stop on?" There's no excuse for that. We should just do that. Stops and traces. Although in a lexical language, it's less like when we're doing the GCD thing. There tends to be less emphasis on that tracing than you might know. I retract that. It's stupid thing to say. We should just do that. One of the work tasks we have is improve Dfn development experience. it's not great.
I have a question which you can ignore, but in the course of getting this to work, there was parallel development of namespaces. So did you have to do extra work to get this to work with namespaces? Because in namespaces you have a question of where things are evaluated and where you're sitting when something is evaluated and where it's left when you
Not
do an
really.
assignment.
One of the that's a good question. If I type hash.iota3, I've got a feeling, yeah. I happen to have IO set to 0 in my session namespace, and I happen to have quad IO set to 1 in my root namespace. That's just a personal preference. And what happens is when I have a function, a dotted function, it is evaluated in the namespace that I'm dotting into. So, for example, if I do ns dot then the body of this is evaluated inside that namespace. It has to be because of this.
Just getting rid of the outside noise.
Okay, we're nearly through it, actually. That's the only consideration in this. Clearly, if you can swallow this, then this has to work the same way. So if you're tracing this, once you're inside the body of this function, you're inside this namespace. And if you want your head to explode, if you start mixing these things inside nested, lexical scopes with dotting all over the place, it can get confusing. Interesting stuff. Any more? Or shall we? All right. Well, thank you for your attention. I'm here all week, so we can talk. I love talking about this stuff. So, if there are any specific examples, and I recommend you load the Dfns workspace because Phil's got some great stuff that he's written in there. There's all sorts of really weird, strange stuff. It's an interesting workspace to look around for examples.